An emergency situation after departure which was routinely trained for. An event which should have been easily managed were it not for an unexpected complication that no one saw coming. A crew left in the dark, overwhelmed and disorientated. A brief 4 minutes of utter confusion, revealing an ironic, cruel twist which needlessly cost the lives of all those on board. This is the complete story of United 266. Today's date is January 18th, 1969. This is the year of the Apollo moon missions, Richard Nixon and the Beatles. In the context of aviation, flying has become far more commonplace and more accessible to the general population at large. Although that said, the mystique and excitement surrounding commercial air travel largely still exists. Flying in the 1960s, particularly internally in the US, means that passengers still move around quite freely without the need for any official form of identification. Many simply show up at the airport half an hour before departure and walk straight up to the gate. Even loved ones walk all the way to the gate without a ticket to send people on their way. With security screening, even in the most relaxed of contexts, not being mandated for another 4 years, the whole experience is a far different affair from what it is today. And so, set against this backdrop on a dreary evening in Los Angeles, United Flight 266 prepares for departure. 266 was a regular scheduled passenger and cargo flight from Los Angeles, California to Milwaukee, Wisconsin, with an en route stop at Denver, Colorado. The aircraft scheduled for this evening's flight was registered as November 7434 uniform, a 4-month-old Boeing 727-200 series aircraft, having been manufactured the year previously on September 1st, 1968, and which had accumulated just over 1,036 hours flight time since new. The 727's design was a compromise between the three major US carriers, United, American and Eastern Airlines. Each of the three had developed requirements for a jet airliner to serve smaller cities with shorter runways and fewer passengers. United had requested a 4-engine aircraft for its flight to high-altitude airports, specifically its hub at Stapleton International Airport in Denver, Colorado. American, which was operating the 4-engine Boeing 707 and 720, requested a twin-engined aircraft for greater efficiency. Eastern, on the other hand, had wanted a third engine for its overwater flights to the Caribbean, since at the time twin-engine commercial flights were limited by regulation to routes with 60 minutes maximum flight time from any en route airfield. Eventually the three airlines agreed on a tri-jet design for the new aircraft, and in partnership with Boeing, the 727 was born. First flown in February 1963, the original 100 series aircraft was followed by the 200 series some 4 years later, receiving FAA certification on November 30th, 1967. In total, 310 727-200s were delivered before the 200 was replaced on the production line by the 727-200 Advanced in 1972. For over a decade, more 727s were built per year than any other jet airliner, with production finally ceasing in 1984, with a grand total of 1,831 having been delivered, the highest total for any jet airliner until the 737 surpassed it in the early 1990s. Yet for all its success and popularity, as of January 2019, 119 of these aircraft had been accidentally lost, almost 6.5% of the entire fleet, and with them the lives of some 4,211 passengers and crew. Little did the crew of United 266 know that they would be included amongst the headcount. The aircraft had arrived in Los Angeles from Denver at about 15:30 local earlier that afternoon, and while on the ground at Los Angeles, a routine en route inspection was performed by United mechanics, who found the aircraft to be serviceable and noticed nothing unusual. This check consisted basically of an interior and an exterior visual inspection of the aircraft for any conditions that might require corrective action. With respect to the aircraft's electrical system, the number 3 generator control panel had been replaced 5 days prior to the accident. 3 hours after its replacement, on the same date, The next crew to operate the aircraft reported number 3 generator under excitation light on before generator connecting to bus. Reset fault, but generator field after 2 tries still would not stay closed with no load on the generator. Disconnected CSD. In other words, despite the crew's best efforts, it was impossible to connect the generator on engine number 3 to the aircraft's electrical system, and as such, the crew had taken steps to deliberately isolate it. The corrective action had therefore been to replace the generator itself, with the system apparently passing all the ground tests necessary to put it back into service. However, 3.5 flight hours later, a different crew had disconnected the newly installed generator because the field relay had again proved problematic. As was previously the case, this crew were also unsuccessful in attempting to connect the generator to the aircraft's electrical system. As such, the number 3 generator was rendered inoperative by ground maintenance personnel and carried as a deferred item in accordance with the minimum equipment list. The Master Minimum Equipment List is a finite list produced by the aircraft manufacturer, in this case Boeing, stipulating the minimum number of serviceable items and components required in order to facilitate dispatch of the aircraft for revenue service. With this information in mind, the operator, namely the customer airline, is perfectly entitled to simply accept the manufacturer's guidance in the production of its own company MEL, or alternatively, they are at liberty to amend the content of the master MEL for their own purposes, provided that any such modification is more rather than less restrictive when compared to the original document. Another aspect of the MEL is that as well as stipulating what specific unserviceable items and components can be carried, it also outlines what alternative procedures may be required under the circumstances in order to compensate for the inoperative equipment, as well as stipulating exactly how long these individual items may remain unserviceable before rectification becomes mandatory. Typically, the more critical the inoperative component, the shorter the allowed period of unserviceability. Within this defined time period, while awaiting rectification, the component is said to have been deferred. In accordance with the dispatch criteria of the MEL, the second officer or flight engineer on board the aircraft during the flight immediately preceding 266 stated that inoperative decals had been placed over the number 3 generator CSD low pressure light, the number 3 generator breaker circuit open light, and the number 3 generator field relay open light. More of what these individual components do later. He also believed that tape was placed adjacent to the number 3 generator position of the AC meter's selector switch. During this period of 3 days, or 42 flight hours where the number 3 generator being deferred, the aircraft had operated through a total of 28 stations, 23 of which possessed line maintenance capability. However, the component was not repaired during this period because of the high demand on aircraft availability and flight scheduling. But in this regard, it should be noted that United were not in breach of any regulations. In fact, the whole MEL concept is designed to give the operator exactly this kind of flexibility, in ensuring that the operation doesn't simply grind to a halt with each and every passing defect experienced by aircraft across the fleet. Conversation recorded on the cockpit voice recorder prior to departure indicated conclusively that the crew were aware that the number 3 generator was inoperative. United procedures prescribed that when only 2 generators are operable, the galley power switch and one of the 2 air conditioning packs should be turned off before takeoff. These systems can be subsequently restored after takeoff, following retraction of the flaps. A broader view of the 727's cockpit highlights the location of the controls governing the aircraft's electrical system on the upper left side of the flight engineer's station. A closer look at the actual layout of the controls of this panel provides a reasonably good schematic of the system and its various components. As a general rule, most modern transport aircraft use 400 Hz alternating current to power much of their electrical equipment, for several reasons. Voltages are easily converted from high to low or low to high, with the higher frequencies used in aircraft electrical systems allowing components to be smaller, yet develop the same power as the 50 Hz devices normally found in the home and industry. In this regard, the 727's electrical system receives its power from 3 engine-driven generators, or on the ground as a backup an APU or auxiliary power unit generator, or alternatively an external ground power source. Indeed, in the example shown, despite the fact that all three engines are running, as the aircraft is on the ground, the APU in this instance is supplying the aircraft's sync bus, meaning that it is the power source for all three generator buses rather than the respective engine generators themselves. The generators each produce three-phase 400 Hz 115 volt AC electrical power. The voltage produced by a generator depends on there being a magnetic field in the generator, with current flowing from the voltage regulator producing this field. The generator's output voltage is sampled by the voltage regulator, which adjusts the current to the field so that the generator's output, when not in parallel, will be 115 volts plus or minus 5. The normal engine start sequence will be engine number 2, then 3, and finally engine number 1. When generator number 2 is producing full voltage, it may be connected to its load bus by closing the generator breaker. The load bus is a distribution point for the power produced by the generator. Heavy load items such as air conditioning pack fans, galleys, and hydraulic B pumps are powered directly from the load buses. Power is also sent to the various circuit breaker panels to power electrical equipment throughout the airplane. Each generator breaker is closed with a switch labelled Gen. When a generator is connected to its load bus through the generator breaker, the generator breaker light next to the generator switch will be extinguished. When the generator is not connected to its load bus, the generator light will be illuminated. To equalise the load in the generators and to protect the electrical system if one generator should fail, the three load buses are connected together by a third set of relays. These bus tie breakers are connected to a common circuit referred to as the tie bus or the sync bus. The tie bus shuttles power among the three AC load buses as power requirements change, but only when the bus tie breakers are closed. If a generator should fail, the tie bus or the sync bus will power the AC load bus associated with that generator through its bus tie breaker. Under certain abnormal or emergency conditions, it may be necessary to reduce the voltage output of the generator to an absolute minimum. The field relay performs this function by interrupting the current flow from the voltage regulator to the generator. With the field relay open, only residual voltage of between 10 and 17 volts will be produced if the generator is rotating. Therefore, each generator has a field relay controlled by the field relay switch on the electrical panel. The light next to the field switch will be on when the field relay is open or tripped, where the generator has been removed from the electrical system. As the next engine is started and its respective generator becomes available, in this instance generator 3, it too will be brought online. Followed finally by generator number 1. An AC generator must be rotated at a constant speed over the entire operating RPM range of the engine, this in order to maintain the appropriate frequency output from the generator. A generator drive unit called a constant speed drive or CSD, which is a hydromechanical device between the engine drive pad and the generator, accomplishes this function for each of the generators. Each CSD contains its own integral oil supply and pumps. So that the oil pressure within the unit can be monitored, a low oil pressure light for each unit is included on the flight engineer's electrical panel, with an amber light illuminating if oil pressure in the unit is too low. To cool the CSD oil supply, an air-cooled heat exchanger is installed in each drive system, with the engine fan stage bleed air continuously providing the required cooling airflow for the heat exchangers themselves. Likewise, there is an oil temperature gauge for each generator drive unit. These gauges have two scales. Oil in temperature is indicated on the lower scale, which is calibrated from 40 to 160 degrees Celsius. The upper scale is calibrated from 0 degrees to 30 degrees Celsius and indicates the rise in the temperature of the oil as it passes through the CSD. Above each temperature gauge is a toggle switch for selecting either the in or rise temperature scales. The in temperature is sensed downstream of the oil cooler as it enters the generator drive. This gives an indication of oil cooler efficiency. The rise temperature is the difference between oil in and oil out temperature and is an indication of heat generated within the drive unit itself, or the actual workload being placed on the CSD. The rise temperature caution range is 20 to 30 degrees centigrade. If the in temperature reads between 127 and 140 degrees centigrade, the operating time limit is 2 hours. With the in temperature between 140 degrees and 160 degrees centigrade, this operating time limit is reduced further to just 50 minutes. To the left of each low pressure light is the disconnect switch for the associated generator drive unit. The CSD can be disconnected by lifting the safety guard and moving the switch to the disconnect position. This action will disengage the mechanical coupling for the CSD from the engine drive pad itself. And in addition, the associated generator breaker and field relays will also be tripped, isolating the generator from any of the electrical system buses. Importantly, this action is irreversible in the air and can only be reconnected on the ground by maintenance personnel. Note in the example shown here that although the number 1 generator is now physically being disconnected from the electrical system, the respective bus tie light remains extinguished, indicating that the demand on the number 1 generator bus, although no longer being serviced by the number 1 generator itself, is still nonetheless being supplied by the remaining generators in the system. The system having been reset by maintenance, the shown example here indicates all generators again powering their respective buses. Since we are dealing with alternating current, we must be certain that the voltages of the various sources we are joining in parallel are in phase. By this we mean that the positive and negative portions of the two voltages that we are connecting occur at the same time. If we join the voltage sources when they were not in phase, the potential exists for serious damage to be done to the generators themselves. In practice, the bus tie breakers are left closed so that a generator loss can be compensated for by the remaining operative generators. Thus, to protect against connecting these generators out of phase, automatic protection circuits will prevent the generator breakers from being closed unless the associated generator is in phase with the other generators already powering the system. Importantly, the bus tie breakers themselves do not have this protective feature. Some AC-powered items are considered to be more critical to safe flight. As such, these items are powered from the essential AC bus, which in turn is supplied by any of the 3 generators directly, without the necessity of its generator breaker being closed. However, unlike the generator breaker, the associated field relay must be closed so as to take advantage of the generator's output. The essential power selector switch on the upper right hand side of the electrical panel controls the selection of a power source for the essential AC bus. Normally generator 3 supplies the essential power, as shown here when all generators are available. The essential AC bus is also powered when external power or the APU is supplying the airplane. The source power priorities for the essential AC bus are generator 3, failing that generator 1, with obviously generator 2 being the only remaining options should all other generators be unavailable. This order of priority is established due to the respective loads on each of the 3 buses, with the general load on bus 3 being the lightest and bus 2 being the heaviest. It's important to note that the selected power source for the essential bus is a manual selection made by the flight engineer in the course of his duties, with the facility for automatic selection of available power source not being available on the 727 back in the 1960s. The current slide shows how the electrical panel would have appeared prior to the departure of United 266. With the number 3 generator inoperative, both its field relay and the generator tiebreaker would have been tripped per the dispatch conditions of the NEL. That being the case, had the essential power switch been left in the generator 3 position, specific failure indications would have been evident to the crew, with a red warning light illuminating on the electrical panel, highlighting the fact that the selected power source was unavailable. Following the established prioritization sequence, therefore, under the circumstances, procedures would have stated that following the start of engine number 1, the essential power switch would have had to have been reselected to the generator 1 position in order to extinguish the failure indications and ensure continued electrical supply to the AC essential bus. In addition to the forward instrument panel adjacent the landing gear lever, a flashing red light labelled warning, push to reset, would also have been illuminated. This light can be extinguished simply by a crew member depressing it, whereas the steady red light on the electrical panel will not extinguish until the essential AC bus is powered from another valid source. Aside from the AC essential bus, given their critical importance, certain of the captain's instruments are protected still further. These are powered from the standby AC bus. As long as the essential AC bus is powered, it powers the standby AC bus. In the event of a failure of the essential AC power in flight, the standby bus will automatically be powered by a static inverter, with this static inverter being powered by the battery bus, if and only if the battery switch is actually on. If necessary, the AC standby bus may be powered directly from the static inverter at any time once the essential power switch is rotated into the standby position. This is normally done when standby AC power is required, but AC power is not available from the airplane's generators or an external power source. Importantly, the essential power selector must be depressed before it can be rotated into the standby position. Finally, on the right side of the flight engineer's panel is an AC meter selector. Each of the 3 engine-driven generators, the APU generator or the external power, can be sampled as well as the voltage and frequency on the sync bus. When a generator is rotating with its field relay open, it will produce 10 to 17 volts residual voltage. The voltage can be read by the voltmeter lower scale by selecting that generator and pushing the residual volts button. When the generator field relay is closed, the generator field is energized by the voltage regulator. Now, normal voltage can be read on the top scale of the voltmeter. It should read 115 volts plus or minus 5. Above the AC meter selector is a frequency meter. This meter will indicate the frequency of the power source selected by the AC meter selector. When selected to generators 1, 2 or 3, the frequency desired is 400 Hz plus or minus 9. If the frequency is not 400 Hz, it can be adjusted using the frequency knob on the left panel. The knob for each generator allows adjustment of the frequency within about 15 Hz spread. Frequency will be indicated only when the generator field relay is closed. When an electrical load is sustained by the engine-driven generator, the load is indicated in kilowatts on its kilowatt meter. There is one for each engine-driven generator. The maximum continuous load for a single generator that is not operating in parallel is 36 kilowatts. It can sustain an overload of 54 kilowatts for 5 minutes. 2 generators operating in parallel are limited to 54 kilowatts total load, and 3 generators in parallel may be operated continuously with a total load of 102.5 kilowatts. The output of each generator is sensed at the generator and also at the load bus. If a difference exists between the two, then this is indicative of a grounding or a short in the feeding lines between the generator and the load bus. This fault, called a differential fault or sometimes a feeder fault, is serious enough to trip both the field relay and the generator breaker, essentially isolating the generator from the rest of the electrical system. With the field relay locked out in such circumstances, it may not be reset without first resorting to a rather protracted abnormal procedure. By way of these gauges, so the flight engineer can maintain a careful watch on generator loads and any possible exceedance. 266 was scheduled to depart the gate at 17:55 local, but was delayed just over 10 minutes till 18:07 because of the inclement weather and loading problems. An extensive area of rain, fog and low cloud prevailed along much of the Californian coastline and into central sections of the state in advance of a frontal system approaching from the Pacific Ocean. The 1900 surface weather chart showed in part a cold front extending southwestward from near San Francisco into the Pacific, and a warm front extending from near San Francisco southwestward along the Pacific coast near Monterey, Santa Maria, and St. Nicholas Island. The official surface weather observation taken at Los Angeles International at 17:55 local and approximately half an hour before the accident indicated 700 feet scattered, measured 1,000 broken, 2,000 overcast, with a visibility of 3 miles in light rain and fog, with a temperature of 55 degrees Fahrenheit, a dew point of 50 degrees Fahrenheit, the wind being 160 degrees at 5 knots, with an altimeter setting of 29.96 inches. Again at 18:27, just immediately after the crash, a later report indicated 800 scattered, measured 2,500 overcast, 4 miles visibility in light rain, fog, with a temperature of 54 degrees Fahrenheit, a dew point of 49 degrees Fahrenheit, the wind from 140 degrees at 6 knots, with an altimeter setting of 29.96 inches. In the subsequent post-accident investigation, the departure controller, who was handling Flight 266, reported that there were 2 large intense weather returns on radar, one of which was due west of the airport and moving eastbound. When the primary target of the flight disappeared, it was just approaching the northern edge of this weather return. The controller also related that pilots were generally reporting rain showers west of the airport in all quadrants, such reports being consistent with ground witness observations. The pilots of Air West Flight 312, which departed from runway 24 1 minute prior to Flight 266, stated that their aircraft entered the overcast at 800 feet. After crossing the shoreline while climbing through 1,000 to 1,200 feet, the flight encountered complete darkness and thereafter was without any reference to an outside horizon. Similarly, the first officer of United Flight 111, which departed from the same runway 4 minutes after Flight 266, reported entering an overcast half-mile off the coast at an altitude of between 1,000 and 1,500 feet.
And we're disconnected. Signal and pin on the right. Take it easy and have a safe flight.
In command of United 266 was 49-year-old Captain Leonard Levison. His total time extended to just over 13,500 hours, with nearly 2,000 of that being gained on the 727 type. In the weeks prior to the accident, Levison had been undergoing type conversion onto the DC-8, but somewhat unusually, that evening he was back in the cockpit of the 727, his first flight in the type for over 6 weeks. His first officer on the ill-fated flight was 33-year-old Walter Schlimmer. His total experience extended to just over 6,600 total piloting hours, with a further 890 hours logged as a flight engineer. Of these combined totals, Schlimmer had acquired just over 1,800 hours in the right-hand seat of the 727, while nearly 2/3 of his total flight engineer time, about 550 hours, was likewise gained on the 727 type. In fact, with over 500 hours working the flight engineers panel on the 727, he was considerably more experienced in the role than the actual flight engineer rostered that evening, who was 29-year-old Keith Ostrander. Ostrander was by far the least experienced of the 3-man crew, having acquired a mere 174 hours total piloting time. In addition, he had gained a total of 460 hours in the role of flight engineer, but critically, only 40 hours of that time had been logged on the 727. His transition training onto the 727 had been completed only a month earlier, with his initial line check being passed successfully a mere 16 days prior to the accident itself.
United 266, cleared takeoff runway 24.
Roger.
United 266. Rolling.
United 266, contact departure control.
United 266, on departure.
United 266, Los Angeles departure control. Radar contact. Turn right heading 270, report leaving 3000.
270, Wilco. What the hell was that? Number 1 fire warning. Okay. Let's take care of the warning. Pull it back for you? Yeah, pull it back. Okay. That puts us on one fucking generator. Huh? That puts us on one generator. Yeah, watch that electrical loading. Everything off. Departure, United 266.
United 266. Go ahead.
We've had a fire warning on the number 1 engine, we've shut it down. And we'd like to come back.
United 266, what is your present altitude? United 266, maintain 3000 and say your altitude. United 266, say your altitude. Maintain 3000. Correction. 3500. What's your altitude now? United 266. If you hear, do not climb above 5,000. Traffic 12 o'clock. 3 miles westbound. A Fairchild en route to Ventura. United 266. Turn right heading 060. United 266. If you hear me, turn right heading 060.
United 266 commenced its takeoff roll on LAX's runway 24 at approximately 18:17 local. The tower controller who observed the aircraft during its takeoff run, and until it was 400 to 500 feet in the air and about 8,000 feet down the runway, noticed nothing abnormal. At 18:18 and 13 seconds, the flight contacted departure control and was instructed to turn right heading 270, report leaving 3,000 feet. The cockpit voice recorder indicated that at 18:18 and 30 seconds, the sound of the engine fire warning bell was heard. At 18:19:05, Flight 266 reported to departure control that we've had a fire warning on number 1 engine. We've shut it down and we'd like to come back. This was the last communication with United 266. Departure control attempted repeatedly to contact the flight during the time period following this transmission, but was unsuccessful. The departure controller who was handling 266 stated that the flight responded to his heading instructions of 270, approximately 5 seconds after the transmission from the flight reporting the fire warning. The aircraft's secondary radar signature, indicating altitude and speed information, disappeared, with movement of the primary target indicating that the aircraft continued to track a relatively straight course. At 18:20 and 30 seconds, when the aircraft was about 10 miles west of the shoreline, the departure controller instructed the flight to turn to the northeast onto a heading of 060, but again received no reply. At this point, the primary target movement indicated instead that the aircraft commenced a left-hand turn, after which the target disappeared from the scope within 2 sweeps. With the radar antenna rotating at a speed of 15 revolutions per minute, this equates to a time frame of about 8 seconds. In addition, the controller also stated that the speed of the target over the ground increased greatly over the same short period of time. Appropriate emergency procedures were initiated following the disappearance of the primary target from radar. It was later determined that the aircraft crashed at approximately 18:21 local, 4 minutes after departure and about 11 nautical miles west of LAX International. Two ground witnesses observed the aircraft taking off from runway 24 at a time corresponding to the departure of Flight 266. One of these witnesses, who identified the aircraft as a 727 based on the engine arrangement, noticed nothing unusual about the aircraft as it flew directly over his car. The other witness's attention was attracted by many sparks, reddish in colour, coming from the right side and rear engine of the aircraft. She observed the aircraft when it was about 1,000 feet high and climbing gradually at what appeared to be a normal speed. Another ground witness, who was located on a hill above Paradise Cove, northwest of the impact point, observed an aircraft over the water, turn to its left and head east back towards the airport. As the plane descended into a thick fog bank, he heard an explosion and saw a flash of light. A fourth ground witness was driving along Malibu Beach in an easterly direction when his son exclaimed,
"Look, Dad, fire."
The man stopped the car, got out, and saw the aircraft on fire, which seemed to be coming from the front of the plane. The aircraft was descending, heading towards the airport, and then it plunged straight down into the ocean. This witness also heard several firecrackers or backfire sounds while the plane was still in the air. The ocean depth at this point is approximately 950 feet. The general orientation of the wreckage path was east-west, covering an approximate area of 600 feet long by 400 feet wide. The largest sections recovered, including the engines, were distributed along a relatively straight line bearing of 262 degrees true. Approximately 50 to 60% of the bulk of the aircraft was recovered, with components from all major sections being identified in the wreckage. Fragmentation and distortion were most evident towards the nose of the aircraft and the right-hand side, with less material from those areas being identified, this providing a clue as to the general orientation of the aircraft at the moment of impact. Conversely, pieces from the left-hand side and aft end were greater in number, larger in size and less mangled. Evidence in the wreckage indicated that the landing gear was in the retracted position and the wing flaps were in the 2-degree extended position. The number 2 leading edge slat, the only slat section positively identified, being confirmed in the extended position at the time of impact. The condition of the small portion of the overall electrical system which was recovered was not considered to be pertinent to the accident investigation. None of the instruments from either the pilot's panel or the flight engineer's panel actually survived the impact itself. With regard to the engines, all 3 were recovered within the 100-foot circle in the main wreckage area. The number 1 engine exhibited only minimal rotational damage, thus indicating that it was not rotating at impact, which is consistent with the reported crew action of having shut the engine down. There were no engine case penetrations, nor was there any evidence of overheat conditions present on engine interior or exterior areas. There likewise was no evidence of gross bleed air duct leakage or rupture. Also recovered were 2 damaged sensor responders, which had been mounted on engines number 1 and 2, and which constituted major portions of the engine fire detector system. These components were subjected to extensive functional testing and were found to be operating within design specification limits. Thus, despite eyewitness accounts to the contrary, there was no evidence of fire on any part of the recovered wreckage, including the number 1 engine and adjacent structure. Both engines number 2 and 3 had sustained massive rotational damage and twisting of the low turbine shafts, indicating high-speed rotation at impact. All 3 thrust reverser assemblies were found in the forward thrust position. As such, the complete destruction and extreme degree of fragmentation of the aircraft, particularly the occupiable areas, were indicative of impact forces far exceeding human tolerance. Apart from one severely mutilated body, only body fragments were recovered, and only 2 identifications, both of which were passengers, were ever to be formally made. 266 flight recorder was recovered still encased in its housing, which had collapsed around it. The flight recorder medium was readable and showed that all parameters were functioning. A datagraph was plotted to reflect 2 separate time periods. The first covered the period commencing with liftoff and ended 1 minute 34 seconds later, when the traces ceased their normal appearance and became wildly divergent, indicating an electrical power interruption. This power interruption occurred 5 seconds after the completion of a 4-second VHF transmission from 266 to Los Angeles departure control. The second time period commenced at an indeterminate later time and lasted 15 seconds, during which divergent traces were recorded for all parameters. Examination of the datagraph reveals that following liftoff, the aircraft climbed approximately 2,300 feet in 1 minute 30 seconds at a steady rate of climb of about 1,500 feet per minute. In the 4 seconds prior to the power interruption, the aircraft descended 50 feet. The indicated airspeed trace shows that the speed increased steadily from 142 knots at liftoff to 212 knots 1 minute later. At this point, the airspeed started to decrease, reaching 203 knots 13 seconds later, at which point it started to increase again, reaching 217 knots when power interruption occurred 21 seconds later. The magnetic heading trace remained on 250 degrees until 30 seconds after liftoff. It then shifted gradually during the next 30 seconds to 270 degrees, where it remained until power was interrupted 34 seconds later. The vertical acceleration trace recorded erratic excursions in the period following liftoff, which tended to flatten out in the final 15 seconds prior to power interruption. During the second period plotted on the datagraph, when power was restored, the initial trace indications on all parameters were particularly erratic. When the power was again lost 15 seconds after being restored, the following readings were being reflected: altitude 630 feet, indicated airspeed 326 knots, heading 264 degrees, and a vertical acceleration of 1.75 g. Thus, as electrical power is lost for the second time, the final snapshot available to the subsequent investigation team is one of an aircraft in a high-speed dive towards the Pacific below. The obvious question now is why? The cockpit voice recorder was recovered almost 6 weeks after the accident. Despite having been immersed in 1,000 feet of seawater during this period, it nonetheless yielded valuable information. A transcript of the recording was prepared, covering the periods following receipt by the flight of takeoff clearance at 18, 16 and 58 seconds. With respect to the recording prior to this time, and in light of the observed electrical power interruptions, all 4 channels of the original tape were monitored to determine whether there was any conversation relevant to the status of the aircraft's electrical generating system, as well as other information which might be pertinent to the accident. The only crew conversations noted in this regard was a reference to the inoperative status of the number 3 generator, to which the captain was made aware. The CVR indicated that the fire warning bell had sounded at 18, 18 and 30 seconds, about a minute and a half after departure. As already mentioned, at 18, 19 and 13 seconds, 5 seconds after completion of the transmission from Flight 266 regarding the fire warning, CVR operations ceased. At a later, indeterminate time, the CVR resumed operation for a period of 9 seconds in total. When the recording terminated a second time, sounds normally associated with impact were not detectable, conclusive proof that power to the aircraft had been lost prior to impact. Although the crew would subsequently report that the number 1 engine had been shut down, and examination of the wreckage would appear to concur with that statement, The CVR transcript would not record the crew actually actioning any part of the engine fire shutdown drill, other than Schlimmer's request of Leverson at 18, 18 and 40 seconds. Pull it back for you? The only definitive verbal confirmation that the drill had actually been commenced. Standard operating procedure thereafter would call for each item of the drill, particularly in light of the fact that they were about to shut down an engine, to be confirmed by the other crew members before being actioned. But, again, nothing of the CVR transcript provided conclusive proof that this is what actually happened. On foot of the applicable thrust lever being retarded, in this instance number 1, the relevant drill, actioned from memory, would subsequently call for the appropriate start switch to be selected off, thereby isolating the engine from the respective hydraulic, pneumatic, fuel, and critically electrical systems. The flight engineer would then reselect the essential electrical bus power source in accordance with the priority sequence mentioned earlier. In the case of 266, of necessity, this would now mean that the selector switch would have to be rotated from the number 1 generator position to the number 2 generator position, as it was now the only remaining power source available. Schlimmer, as the pilot monitoring, again under the supervision of the other 2 crew members, would then have pulled the engine's fire switch and discharged the associated agent in an effort to extinguish the fire. Were these actions unsuccessful and indications of a fire to persist, the drill would subsequently call for a second bottle to be discharged after a period of 30 seconds. From the transcripts, Schlimmer appeared to recognise immediately the gravity of their new technical predicament. The required procedure in this critical configuration called for the electrical loads to be carefully monitored, and efforts were to be made to protect the remaining generator from overload. The generator breaker switch on the remaining generator, in this case number 2, was to be confirmed closed, ensuring that it, as the sole remaining generator, was in fact connected to the electrical system. Likewise, in order to confirm the disconnection of the unserviceable generators, their respective breaker switches would be deliberately tripped. All 3 bus tie switches would then be confirmed closed, this to ensure that the remaining generator was in a position to power necessary items connected to the other generator buses. And finally, in an effort to offload some of the bigger, non-essential electrical users, the galley was depowered, and as was the air conditioning system by way of the pack switches prior to extension of the flaps, typically a phase of low-level flight where they would not be needed. Continuously thereafter, the flight engineer's responsibility was to monitor the system closely and take further appropriate action if it became necessary. At 18, 19 and 13 seconds, 5 seconds after the end of this transmission to departure control, both the CVR and flight recorder operations terminated simultaneously. In addition, the subsequent statement from the departure controller stated the transponder target of the aircraft disappeared off the radar scope at approximately the same time. It can therefore be concluded that the aircraft lost its only operating generator, that being generator number 2, at this exact moment. This analysis of the events leading up to and including loss of electrical power is based primarily on the cockpit voice recorder. Although the CVR provides no indications as to the flight engineer's actions during this period, several deductions in this regard can, however, be made. At the time of the fire warning, the essential power selector switch was probably selected to the number 1 engine. His first action, as prescribed by the emergency procedures, would have been to move this switch from the number 1 engine position to the number 2. That he in fact accomplished this step prior to the shutdown of engine number 1 is confirmed by the fact that the CVR, which is connected to the essential bus, remained operating after the number 1 engine was shut down. The number 1 engine would have been shut down by selecting the engine start lever to cut off, which probably occurred not later than time 18, 18 and 52 seconds, when the first officer posed the question, "Everything off?" This action energizes a time delay circuit that in turn trips the generator field relay and the generator breaker within 5 to 9 seconds. Accordingly, by 18, 19 and 01 seconds at the latest, the number 2 generator would have been carrying not only the essential bus loads, but also the loads of all 3 buses, since it can be assumed that all 3 bus tiebreakers were still closed. Subsequently, at 18, 19 and 13 seconds, it was deduced that the number 2 generator tripped offline, leaving the aircraft with absolutely no generator power at all. Although this was the most probable explanation for power loss to the recorders, explaining the reason behind such an event would prove far from straightforward. It was apparent, however, that placement of the entire electrical load of all 3 generator buses, plus the essential bus, onto the number 2 generator alone was instrumental in tripping the sole remaining generator offline. Such a condition could have resulted from appropriate reductions in the electrical load not being accomplished subsequent to the loss of the number 1 generator. Single generator procedures, as mentioned previously, prescribed that the galley power switch and both air conditioning pack switches should be turned off, but one of the pack fans and the galley power switch should already have been in the off position at the time the number 1 generator was lost, this being a condition of NEL dispatch, while the flaps were still in the extended position. This left only the remaining pack fan switch to be turned off to reach the prescribed load level. Accordingly, it's difficult to believe the crew mismanagement of the electrical system produced an overload condition. However, if any one of the various components turned off were not in fact disengaged from the electrical power source, an overload could result. Even if the electrical load had been reduced to the proper level, it is possible that an overload condition resulted from the remaining generator supplying a lower than normal amount of voltage. If an overload condition did in fact occur, the severity of the condition, as well as the manner in which it was imposed, may have been significant. Extensive ground and flight testing conducted after the accident indicated that during certain extreme overload conditions, sufficient induced interference may be present on some 727 aircraft to inhibit proper operation of the number 2 time delay circuit of the protection panel. The expected action of this panel during such an overload would be to trip the bus tiebreaker, thereby isolating the generator and its load bus from the rest of the system, which usually clears the overload. However, if the number 2 time delay circuit is disabled by the induced interference, the number 1 time delay circuit will continue to sense the overload and, after 5 to 9 seconds, will trip the generator control relay and the generator circuit breaker, thus removing the generator from the system. Applying this theory to Flight 266, it is possible that the sudden shift of the entire electrical load to the number 2 generator produced a shock load of sufficient dimensions to trigger the sequence we've just described. Regardless of the cause of the number 2 generator tripping offline, the loss of all generators should not in itself result in the loss of all electrical power. Yet, this is exactly what the investigators believed had happened. The 727 is equipped with a standby power system, completely separate from the normal electrical system, which supplies power from the battery to those instruments and radios necessary to allow the aircraft to continue to be flown safely from the left-hand seat under instrument conditions. The standby system can be activated if the battery switches on by placing the essential power selector switch into the standby position. The subsequent investigation, however, believed that the standby system was not operational during the period subsequent to loss of the number 2 generator and prior to the brief restoration of electrical power at an indeterminate later time. If the standby system had been activated, the crew would have had available the number 1 VHF transmitter and receiver, and therefore would have been able to communicate with LAX departure control. The flight, however, not only failed to respond to controllers' repeated calls over the next 80 seconds, but also reacted to the heady instruction of 060 by turning in the opposite direction. It thus appears that the VHF communication system and, by the same token, the standby system were thus not functioning. Furthermore, if the standby system had in fact been activated and had operated properly, there would have been no reason to switch the essential power back to the number 2 generator, which was the setting when power was briefly restored and the aircraft apparently went out of control. Based on this assumption of lost communications, the NTSB arrived at the conclusion that the standby system was not activated, or in fact had actually failed to function in the event that the flight engineer had attempted to do so. With regard to the fact that the aircraft was flown on a straight course after losing the number 2 generator, without having reference to attitude instruments, it should be noted that the captain would have had adequate time between the fire warning and the loss of the number 2 generator to level the aircraft and trim it up for 2-engine flight. Unless he had consciously attempted to change heading, the trimmed condition would have kept the aircraft on a relatively straight course, at least for the brief period of time involved. Moreover, when the aircraft lost power and the cockpit became darkened, the captain may have had some outside reference, even if only to a cloud layer. Although the available evidence did not permit a conclusive determination as to why the standby system was not activated or why it failed to function, one potential explanation involves the relative positions of the battery and galley power switches. November 7434 uniform was a QC model aircraft, allowing for rapid conversion between passenger and cargo configurations. As such, the requirement for additional smoke detectors to be fitted had resulted in the battery switch being relocated to a position just above the galley power switches. Both are on-off toggle switches. When the number 1 generator was shut down, one of the first actions of the flight engineer would have been to reduce the electrical load. One of the components which should be off when operating on one generator is thus the galley power. Accordingly, even though galley power should have been off since prior to takeoff, the flight engineer may have instinctively brushed the galley power switch with his hand to make certain it was off, but hit the battery switch instead. If the battery switch had been inadvertently turned off in the above manner, there would have been no indication of its being off in the cockpit at the time. Thereafter, when the number 2 generator was lost, an attempt to activate the standby system would have proved unsuccessful with the switch in this configuration. In reality, however, given that the battery switch, in light of its importance, is guarded specifically to protect against just such an inadvertent selection, this particular theory, in my opinion, is somewhat far-fetched. Assuming then that the battery switch was not selected off, there are several other possible explanations as to why the standby system was not activated. The first involves United emergency procedures for loss of all generators. As prescribed at the time of the accident, these procedures included no mention of switching to standby, but rather prescribed that any generator field relay should be closed and the essential power selector placed on the operating generator. It's therefore possible that following loss of the number 2 generator, the flight engineer, either directly referring to the checklist or with it in mind, repeatedly attempted to bring the number 2 generator back online. On the other hand, though, United instructors subsequently testified that the flight engineers had been trained to attempt restoration of generator power only the once before switching to standby. Furthermore, if the flight engineer had not attempted to switch to standby reasonably soon after the number 2 generator was lost, either the captain or the first officer most probably would have reminded him to do so. A second possible reason that the standby system was not activated if the battery switch was on involves the essential power selector switch itself. This switch must pass through a gate in order to be moved into the detented standby position. The purpose of the detent is apparently to ensure that the operator is aware that he is switching it to an emergency operation. Although the flight engineer should have been familiar with this characteristic of the switch, it is possible that when the cockpit became suddenly and unexpectedly darkened upon the loss of the number 2 generator, he moved this switch counterclockwise until he encountered the obstruction and assumed it was in the standby position. In fact, it would have been in the APU position, which is a dead circuit in flight. It's also possible that the standby system failed to function because of a malfunction in the battery or the battery charger. This could also explain why the crew eventually switched the essential power switch from the standby back to the number 2 generator, even though that generator was supplying low voltage. A battery malfunction could also constitute a differential fault, which might have been the cause of the number 2 generator initially tripping offline in the first place. Regardless, When all generator power was lost, and assuming the standby system was not activated or failed to function, the only lighting available, apart from that which might have been provided by flashlights, would have been the emergency exit lights over the door leading to the passenger compartment. These lights are powered by a separate battery and are activated automatically when electrical power is lost. If that happened, it can be assumed that the flight engineer was attempting either to activate the standby system or to bring the number 2 generator back online, while the pilots were doing their best to control the aircraft in a semi-darkened cockpit with no attitude instruments. If the battery switch were off, thus making it impossible to activate the standby system, it's difficult to comprehend why one of the crew members did not think of this possibility and check the switch. The only explanation is that the cockpit was in a state of confusion and that each of the crew was busily engaged with his own immediate problems, with the consequence that a switch such as the battery, which is presumed to be on at all time, was actually overlooked. It's also important to state that from the crew's perspective, the only physical indication that the battery switch would not have been on, with loss of the last remaining generator, would have been the absence of certain emergency lighting in the cockpit. But again, under the existing conditions of confusion and high workload, their absence may also not have registered with any of the 3-man crew. As reflected by the reactivation of the flight data recorder and the cockpit voice recorder for 15 and 9 seconds respectively, the number 2 generator came back online at some later indeterminate time. Although the precise moment in time when the 2 recorders became reactivated, or whether they were reactivated simultaneously, could not be determined, some rough approximations in this regard can be made. The radar controller who was handling Flight 266 estimated that the primary target of the aircraft disappeared from the radarscope within 2 sweeps, or 5 to 11 seconds after she directed the flight to turn right onto a heading of 060. The controller made 2 successive transmissions containing this heading direction, the first of which ended at 18:20 and 33 seconds, while the second terminated at 18:20 and 44 seconds. Primary target disappearance, based on flight tests, should have occurred as the aircraft was descending through 700 feet, and thus can be closely related to the final remarks at the end of the CVR. 3 seconds prior to CVR termination, the first officer said to the captain, "Keep it going up, Arnie, you're 1,000 feet. And 2 seconds later said, "Pull it up." It therefore appears that the CVR ceased operation at about the same time the primary target disappeared. This conclusion that the CVR terminated prior to impact, while the aircraft was still airborne, is substantiated by the absence of impact sounds on the recording. In view of the absence on the CVR of the departure controller's transmissions during these periods between 18:20 30 seconds and 33 seconds, and again between 18:20 40 seconds to 44 seconds, it can be further approximated that the CVR terminated 10 or 11 seconds after completion of the second of these transmissions, and had resumed operation somewhere in around 18:20 45. The approximate time when the flight data recorder ceased operation following the reactivation period of 15 seconds can be deduced only if the final trace indications can be considered reasonably valid. Thus, if the final altitude trace of 630 feet is accepted as a reasonably accurate reflection of the aircraft's altitude at that point, it could be concluded that both the recorders ceased operation at the very same time. It would then follow that the flight recorder resumed operation some 6 seconds prior to the CVR. The reason underlying restoration of the number 2 generator are difficult to assess, again due to the lack of physical evidence. However, the fact that components powered by the essential bus, the number 2 bus and the number 1 bus had all been confirmed operational for periods of time after the loss of the number 1 generator indicated that the number 2 field relay, circuit breaker and bus tie breaker were all closed, and that the essential power selector switch was positioned to the number 2 generator. In this condition, the remark made by one of the crew following restoration of the power that the field's out undoubtedly was a reference to the field relay light being off, as it should have been since the generator was now operating. Test results confirmed that a low voltage condition of approximately 50 volts, as opposed to the normal voltage output of 115, existed when the power was restored on Flight 266. This power level was simulated by inflicting the normal operating loads of 2 generators instead onto just one. If the problem which caused the number 2 generator to trip offline still existed, it is possible that the flight engineer in Flight 266, in a last desperate attempt to restore power, manually closed the number 2 field relay and held it closed to keep the protection circuitry from tripping it out. Seconds later, as the aircraft entered an abnormal attitude, the NTSB suggested that his hand may have been thrown from the panel, thus causing the complete loss of the remaining generator power available. Although this, to be honest, is complete conjecture. The fact that the 2 recorders operated for different lengths of time is difficult to rationalise. The most plausible explanation is that these units require different levels of voltage for their operation, and therefore, as the voltage output of the number 2 generator built up and then receded, the CVR either became activated later or deactivated sooner than the flight recorder. Regardless of the reasons underlying restoration of power, it appears that the flight engineer was aware that the predicament of the flight was not yet remedied. This conclusion is based on his remark several seconds after power was restored, that we're gonna get screwed up, followed by, I don't know, which it was believed was a statement on his part that he really didn't understand what was going on. Without understanding from the outset exactly what, or indeed if, the observed electrical power outages had any role to play in the unfolding events surrounding the loss of 266, the investigation team nonetheless set about attempting to establish their root cause. As part of the routine investigation process, an extensive series of ground and flight tests were conducted subsequent to the accident in an attempt to shed some light on the electrical and associated problems experienced by Flight 266. These tests generally showed that during 1 and 2 generator operations, the aircraft electrical system could more than adequately carry the design load, provided prescribed procedures were followed. Tests also showed that electrical outages had no significant adverse effect on the flight control system. In other words, following complete electrical failure, this should have no adverse effect on the aircraft's ability to stay airborne. Among the more relevant information uncovered by the test, however, was the fact that during certain extreme overload conditions, as would have been the case with 266, with the engine shutdown resulting in all electrical demand now being shifted to the sole remaining generator, sufficient induced electrical interference may be present on some 727 aircraft to inhibit proper operation of what is called the number 2 time delay circuit of the protection panel. The expected action of this panel during such an overload would be to trip the bus tiebreaker, thereby isolating the generator and load bus from the remainder of the electrical system, thus clearing the overload. However, if the number 2 time delay circuit is disabled by the induced interference, the number 1 time delay circuit will continue to sense the overload and, after a period of 5 to 9 seconds, will trip the generator control relay and the generator circuit breaker, thus removing the generator from the system. Flight tests indicated that, particularly with the battery switch in the off position, the generator field relay would trip prior to the bus tie breaker in approximately half the time under overload conditions. It was also attempted during the test to simulate the voltage condition reflected on the CVR at the point when power was restored for 9 seconds. These tests indicated a low voltage condition of 50 volts at that time. This power level was simulated when a single generator was brought online while the system demand actually called for 2. The remaining question, so, concerns the causal relationship between the electrical system problems which resulted from the shutdown of Engine 1 and the eventual crash. Flight tests indicated that electrical power outages would not have a substantial impact on the flight controls of the 727. It therefore appears that the most significant adverse effect of the electrical power loss on the capability of the pilots to fly the aircraft would have involved the attitude reference instruments, which are so critical to the operation of an aircraft under instrument conditions. The basic instrument in the cockpit from which any pilot in instrument conditions derives attitude information is the attitude indicator, or more colloquially referred to as the artificial horizon, which in turn receives data from an electrically powered vertical gyro. When the aircraft was initially started up, this vertical gyro would have established a vertical plane with reference to the ground. When electrical power was lost in flight, a flag labelled gyro would have appeared in the lower face of the attitude indicator instrument, and the indicator itself would have rolled to a 90-degree pitch-up attitude. The only other instrument in the cockpit which provides attitude information, the turn needle, is controlled by an electrical signal and therefore would have also been rendered inoperative. When the electrical signal to this instrument was removed, the needle would have remained centred, thus indicating level flight. The gyro itself would have started to coast down. Despite this rotational rate starting to decay, a certain amount of stability would have been retained in the gyro assembly. However, if the aircraft attitude were altered from the level position by climbing or descending or banking left or right, precession of the gyro gimbals would have occurred. In other words, as the gyroscope's rotational rate slowed, its steady, fixed position in space would have become compromised as the aircraft manoeuvred, and as such its fixed reference to the horizon would have started to falter. Upon restoration of power, the attitude indicator presentation of 90 degrees pitch up would have rolled back towards the attitude of the vertical gyro. In addition, the vertical gyro would have gone into its fast erection cycle. However, if the gyro had precessed during the period electrical power was lost, or if the aircraft were in a position other than level flight when power was restored, the gyro would not be referenced to the ground, but rather would be sensing and erecting towards a false vertical plane. Accordingly, if the captain had attempted to change the attitude of the aircraft towards an instrument indication of level flight under the above conditions, he would have been manoeuvring the aircraft with reference to a false horizon, which would have served to aggravate further an already serious orientation problem. The gyro warning flag would have remained in view during the brief period when power was restored, as under the low voltage condition prevailing after power restoration, there would have been no power supplied to the flag retraction circuitry. Nevertheless, when the cockpit light suddenly came on upon restoration of power, causing the loss of whatever outside reference may have been available, the NTSB believed it most probable that the captain would have turned his attention to the gyro horizon as a last resort in attempting to establish the attitude of the aircraft. On the other hand, the intensity of the cockpit lights, in view of the low voltage condition, may not have been bright enough to allow the pilots to view the instruments themselves. In either event, the pilots would have been without a reliable attitude reference, either inside or outside of the aircraft. The reasons underlying the left turn commenced by 266 prior to disappearing from the radar scope could not be conclusively determined. The captain may have been attempting to turn back towards the airport and elected to do so to the left in view of terrain to the north or right of the aircraft in its current position. It was also possible that the turn represented the early stages of disorientation with regard to the attitude of the aircraft. In any event, once the turn was initiated, the difficulty of the captain in determining the attitude of the aircraft would have accelerated. This conclusion is substantiated by the remarks of the first officer during the final moments, which apparently were prompted by his concern about the rapid loss of altitude. Even if the captain had pulled back on the yoke in response to those remarks, the descent would not have been arrested unless the wings had been levelled. Without any attitude reference, the captain may have held the yoke as nearly centred as possible, thus causing the left turn to tighten as the aircraft descended to impact. One final matter which warrants comment concerns the fact that the captain on Flight 266 had been flying only DC-8s since December 2nd, 1968. Apparently, there is no difference between the 727 and the DC-8 in terms of cockpit configuration and instrument location that could have significantly affected the captain's reaction under the emergency conditions, other than the fact that the DC-8 has no standby electrical system. Nevertheless, the relative lack of familiarity in itself, resulting from 7 weeks' absence from the aircraft, may have posed problems, albeit minor. On balance, therefore, there's insufficient evidence to support a conclusion that the captain, having flown only DC-8s in the 7 weeks preceding the accident, was a contributing factor. Nonetheless, the board believes this type of scheduling could potentially lead to a compromise in safety. Accordingly, the NTSB noted with approval that United subsequently amended the procedures. In relation to the case under review, having most recently only flown the DC-8, United's revised procedures would have seen the captain undergo a familiarisation flight or a series of flights on the 727 before being released to operate the type once more in an unsupervised capacity. On the basis of the evidence gathered from the wreckage and the recorded crew conversation in the final moments of the flight, it's apparent that the aircraft was in an abnormal attitude when it struck the water. The limited scatter of the wreckage is indicative of a steep impact angle, while the fragmentation pattern indicates that the aircraft impacted at a relatively high rate of speed in a right wing low, nose low attitude. The exclamation of the first officer during the final seconds of "keep it going up, you're 1,000 feet, pull it up," further demonstrates that loss of attitude orientation was experienced prior to striking the water. Based upon the fact that parts of all major elements of the aircraft were either recovered or were identified by means of underwater video, coupled with the fact that these parts were all located within a relatively small area on the ocean bottom, it can be concluded that the aircraft was essentially intact at impact. The extensive fragmentation of the wreckage precluded any determination concerning the condition of the control system at impact. However, there was enough evidence to conclude that the number 2 and number 3 engines were capable of producing a sufficient level of power to sustain the aircraft in flight, despite the fact that the number 1 engine had been shut down. In attempting to determine the factors underlying the loss of attitude reference, the thrust of the investigation was primarily focused on 2 areas. Firstly, the circumstances surrounding the fire warning on the number 1 engine, and secondly, the nature of the electrical system problems experienced during the flight, including their effect on the capability of the crew to fly the aircraft. All of the records examined during the course of the investigation disclosed that the aircraft had been maintained in accordance with applicable company and Federal Aviation Administration directives. Particularly in the context of the fire warning system, the accident aircraft presented no reports of prior fire warnings on the number 1 engine, or any condition to which the fire warning experienced in Flight 266 might have been related. With respect to the United 727 fleet in general, a total of 73 in-flight shutdowns due to fire warnings were experienced during the period from January 1966 through March 1969. Of these, only 10 were false warnings. That's to say, warnings for which there was no identifiable cause, such as an overheat or fire. Most of the engine shutdowns, in which no actual fire occurred, were due to overheat resulting from hot, high-pressure engine bleed air leaking into the fire warning sensor area through failed or cracked ducting. Research into the records concerning the 727's fire warning system also disclosed that Boeing Service Bulletin number 2615 was issued on the 7th of May 1968. Its objective was to reduce false fire or overheat indications on airplanes using the Lindbergh engine fire detection system. The bulletin provided for optional replacement of the fire sensor switches with alternatives which activated at a slightly higher temperature. Of note, however, was the fact that, being an optional procedure, United had chosen not to incorporate the modification into the accident aircraft. In what came as somewhat of a surprise, as the investigation progressed and evidence was gathered, investigators failed repeatedly to find any evidence of fire on any part of the recovered wreckage, including the number 1 engine and the adjacent structure. It's difficult to reconcile this lack of physical evidence of fire with ground witness observations of fire or sparks in flight. It is possible, however, that a phenomenon did in fact occur which provided ground witnesses with a view of flames or the appearance of sparks. One such possibility would be a transient compressor stall on one of the 2 operating engines after the aircraft assumed an unusual flight attitude prior to impact. One other possibility, although remote, is a transient compressor or turbine rub, or the ingestion of a small particle by one of the 2 operating engines, which could also result in the emission of sparks. Such an occurrence would not necessarily impair the operation of the engine, nor would evidence of it necessarily be detectable after impact, and the resultant massive deformation of engine rotating components. To the extent that these two sources of evidence were deemed inconsistent, the NTSB were of the view that physical evidence, or lack thereof, is more persuasive than the observations of several witnesses on a dark, rainy night. It was therefore their final conclusion that an in-flight engine fire had never actually occurred, and that ultimately engine number 1 had been shut down unnecessarily. The remaining possible causes of the fire warning, once an actual fire is discounted, are an overheat or a false warning. The physical evidence derived from the wreckage, although negative in regard to both of these possibilities, cannot be considered definitive. Accordingly, no conclusive reason for the fire warning could be established. Based solely on past history of fire warnings on the subject type of engine, the most probable cause of the fire warning was an overheat condition within the engine compartment, which in turn probably resulted from a pneumatic duct leak. Even if such an assumption were to be made, the board did not believe that United's failure to modify the fire warning sensor could be considered a causal factor, as the alternative sensor design merely delays the activation of the fire warning. It does not reduce the number of genuine warnings themselves. In any event, the number 1 fire warning and shutdown and the result reduction of available generators to 1 should not alone have caused subsequent loss of attitude orientation and crash of the aircraft, inasmuch as the aircraft should have been operable with only 1 generator or indeed with none at all. In other words, the crew should have been able to land the aircraft safely if there had been no problems other than the loss of engine number 1. As the investigation progressed, it became increasingly apparent that it had been the electrical power problems encountered by 266 which had been most directly responsible for the eventual loss of orientation. As such, the following analysis of the cause, nature and effect of these problems forms a chronological discussion of the pertinent events which occurred on Flight 266 that fateful January night. The CVR showed that Leverson and his crew were aware that the number 3 generator was inoperative prior to departure. It can therefore reasonably assume that the flight engineer turned off the galley power switch and one of the 2 air conditioning packs prior to takeoff, as prescribed by the MEL dispatch procedures. Based on the cockpit voice recorder and the flight data recorder, the takeoff and early portion of the climb out were normal. The only indication of anything unusual during this period was the observation of one ground witness that sparks were emanating from the engine located on the rear right-hand side of the fuselage. As noted previously, one possible explanation for the reported sparks would be a transient compressor or turbine rub, or the ingestion of a small particle into the engine. It's also possible that the sparks were an early manifestation of the electrical problem, which later was to cause the loss of all generator power. In truth, however, these suggestions amount to no more than conjecture. At 18, and 30 seconds, the sound of a warning bell was heard in the cockpit. 4 seconds later, the first officer identified the bell as the number 1 fire warning, and shortly thereafter, the recorded conversation indicated that he pulled back the thrust lever on the number 1 engine, as prescribed by the engine fire emergency procedure. Commencing at 18, and 45 seconds, the first officer stated twice that the aircraft was now on 1 generator. The captain responded by stating, "Yeah, watch that electrical loading." It's therefore apparent that the crew was clearly aware of the limitations imposed by the reduction in available electrical power. At 18, and 52 seconds, the first officer posed the question, "Everything off?" which could have been directed to the flight engineer as a follow-up to the preceding remark by the captain to assure that all unnecessary electrical powered components were indeed turned off. It's plausible that given the flight engineer's level of inexperience on the type, the first officer was confirming that none of the significant electrical reconfiguration had been overlooked. 5 seconds after the first officer's radio call to departure at 18, 19 and 5 seconds, outlining the flight's predicament and the desire to return, simultaneously 266 secondary radar transponder target was lost and CVR operations ceased, This, the investigation team believed, was the exact moment that the shock loading on the one remaining generator caused it to trip offline, plunging the aircraft into darkness. But the CVR had been operating during the intervening period between the number 1 engine shutdown and loss of the number 2 generator, conclusively proving that the flight engineer had indeed reconfigured the electrical system in order to preserve those critical items being powered from the essential electrical bus. But that said, even with the subsequent and unexpected loss of the last remaining generator, the most critical of instruments needed to successfully fly the aircraft should still have been operational due to their being powered from the standby bus, an even more critical power source than even the essential bus. In truth, the 727 had been designed that this was expected to be the aircraft's impenetrable very last line of defence. But such expectations were never realised, and largely based on the aircraft's inability to communicate further, the aircraft's radios being one such last line of defence item. The investigation team surmised that the relevant standby system had either failed to be energised, or the flight engineer's manual attempts to physically select it had been unsuccessful. Although theories were proposed as to why the aircraft now found itself in this fraught predicament, these were in fact nothing more than just that, theories, and fell short of what could be considered definitive and conclusive proof. But it was this predicament, rather than the loss of a power plant so shortly after takeoff, which would prove to be the ultimate downfall of United 266. Starved of electrical power, the gyroscopic inner workings of the attitude indicator began to spin down and lose their stability, no longer being able to maintain their orientation in relation to the dark, unseen horizon outside. In attempting to manoeuvre the aircraft back towards LAX, Leverson's efforts to save his aircraft would in fact only compound the attitude gyro's increasing loss of stability. Finally, at a later undefined time, for reasons still unknown for sure, electrical power was briefly restored to the cockpit instruments. However, far from being a solution to the problems, the investigation team believed that as the attitude gyros again began to power up, they would have done so without the benefit of a stable, truly horizontal platform, and as such would never have been able to restore themselves to their previous true orientation with regard to the hidden horizon outside. Undoubtedly being cognitively saturated, Leverson did what most other pilots would have done in the same situation. With power being restored, he turned one final time to the attitude indicator, an instrument he had implicitly trusted his whole career, in an effort to orientate the aircraft and bring stability to the situation they were in. But just when he was depending on it most, the internal gyroscopic mechanisms of the instrument presented a view of the world outside which was false and completely misleading. What was presented as straight and level flight was anything but, and convincingly fooled by what was being presented, Leverson's subconscious decision to follow the instrument's false promises took the aircraft further into the realm of upset, resulting in an uncontrolled descent and subsequent impact with the cold waters of Santa Monica Bay below. In a letter dated July 11, 1969, the chairman of the safety board recommended to the administrator of the FAA that the automatic switching of essential power to standby power upon loss of all generators be made a mandatory requirement for all turbine-powered aircraft. It was further recommended that until such time as the above requirement could be implemented throughout the industry, the emergency checklists for all airlines pertaining to loss of all generators required that the flight engineer or captain, if appropriate, check to ensure that the battery switch is on, then immediately switch essential power to the standby or emergency position. It was the safety board's view that this would give the captain the instruments and lights necessary to fly the aircraft, while the flight engineer could troubleshoot the electrical system. In his response of July 28th of the same year, 1969, the administrator stated that indeed it was the FAA's intention that all future type certification would require such modification, and that current in-service large transport aircraft would be retrofitted with an independently powered secondary attitude indicator. a requirement which became mandatory after August of 1970. These measures, he believed, in conjunction with amendments to crew emergency procedures, would greatly mitigate future reoccurrence of what had been experienced on United 266. In order to remove any doubt as to the status of the standby system during a loss of all generator emergency, the NTSB further recommended that flight engineers on the 727 be provided with a positive indication on their panel when the standby system is being powered from the battery. Such an indication could take the form of a light, such as that installed on the 747 type for the same purpose. The light will become illuminated when the standby system is activated, with another alteration which might be considered in connection with the foregoing recommendation being the transfer of the standby feature from the essential power selector switch to a separate on-off toggle switch, which again is the arrangement on the 747. The addition of such a switch would not only serve to simplify activation of the standby system, but would also facilitate troubleshooting the generators when the standby system is on. The FAA also took several other actions in response to what had been learned from United 266, and as a result of information developed during the early stages of the investigation, they subsequently issued an AD, or an Airworthiness Directive, on January 31, 1969, requiring 727 operators to provide a means to prevent inadvertent operation of the battery switch in those aircraft where the battery switch was located within 10 inches of the galley power switch. 6 months later, in August of the same year, they proposed a further AD requiring the installation of a capacitor for the purpose of filtering out electrical interference which may be present to a sufficient extent on some 727 aircraft, which, under an overload condition, may cause the generator control panel to disable the generator before opening the bus tie circuit breaker. 1 month later, and yet another AD was issued, which aimed to strengthen the existing generator overload protection circuitry. During the investigation, a considerable amount of attention was focused on the minimum equipment list, or the MEL, and more specifically on the question of whether the MEL, with regard to the required number of operative generators, was adequate in light of known events surrounding United 266. The MEL for the 727 was established through extensive ground and flight testing, after which it was agreed through meetings with the involved parties, including the FAA, Boeing and United, that the aircraft would be airworthy with 2 generators. An additional margin of safety was provided by the standby system, through which electrical power could be supplied from the battery to those instruments and components necessary to enable the pilot to make an approach and landing under instrument conditions. The 3rd generator was included on the 727, not as a matter of safety, but rather to enhance schedule dependability. For example, if one of the 3 generators should become disabled, the aircraft would still be able to operate without delay through small fields which lacked the maintenance capability to repair such a component. Subsequent to certification, the 727's electrical system had been altered in minor respects only, which primarily involved changes in procedures rather than increases in loading. Furthermore, the flight tests conducted after the accident substantiated the ability of the aircraft to carry design loads during 1 and 2 generator operation. Finally, and perhaps most importantly, the fact that Flight 266 departed with 1 generator inoperative cannot be classified as a causal factor in the accident. The shutdown of the number 1 engine, the loss of the number 2 generator, and the non-activity of the standby system are all unrelated to the number 3 generator in terms of cause. In view of these facts, the NTSB believed that there was no basis upon which to recommend that the MEL for the 727 be revised to require that all 3 generators be operative. At the same time, they did believe that repairing components beyond those required by the MEL as soon as practicable is consistent with sound maintenance and engineering practices. Furthermore, it can even be said that maintaining such components in operating condition has the added effect of enhancing safety in as much as it increases the available degree of redundancy. Finally, in closing the report, the NTSB had these cautionary words to say about the 727 electrical system and the FAA's proposed mitigation efforts. The board believes that these steps should go a long way towards preventing the reoccurrence of a similar accident. At the same time, we recognise that effective prevention is limited by the fact that the lack of physical evidence has not allowed a conclusive determination of why the number 2 generator was lost and why the standby system was not activated or failed to function. Our concern in this instance is increased by the several incidents subsequent to this accident, which have likewise involved loss of all 3 generators on the 727. Despite the generally excellent performance history of the 727 electrical system, the possibility remains unless and until the reason underlying these power losses are determined that a common problem within the system is responsible. Accordingly, the board urges all 727 operators to be particularly thorough in investigating any incidents of a similar nature in order that every possible effort be made to uncover this problem should one exist. In so doing, the legacy of United 266 was written. Never again would Western-designed aircraft be left so fundamentally vulnerable following a significant electrical power outage. 38 souls and a perfectly airworthy aircraft had been lost, but history will forever recall that such sacrifice was not in vain, and has served to enhance aviation safety from that day to this. This was the story of United Flight 266, lost on the night of January 18th, 1969, to the dark waters of the Pacific Ocean.